Good evening, sir.
Vijay, good evening. Vijay,
Yes, sir.
yeah, please.
Sir. Okay, okay.
Let's pray. Almighty God, we thank you for blessings with us, with this wonderful opportunity to gather here on sixth day of our faculty development program. We are grateful for the knowledge, wisdom, and guidance we continue to receive each day. We also seek your blessings upon the Director of IPE, Professor Srinivasa Murthy for kindly providing valuable leads of resource persons for the FDP. We humbly seek your blessings upon the esteemed resource person, Professor Y. Ramakrishna Garu. Grant him wisdom, good health, and continued success as he shares his valuable knowledge with us. May his words enlighten our minds and inspire us to learn and grow. As we engage with the topic cross sectional data analysis, seek your guidance to cultivate clarity of thought, analytical ability, and a spirit of inquiry. Bless the management of Little Flower for their constant support in conducting such FDPs. Bless the organizing committee for their dedicated efforts in making the FDP a success. Bless all the participants with attentive mind, open hearts, and the eagerness to learn and grow. May this session enrich our understanding and help us apply knowledge effectively in our academic and research endeavors. We ask this prayer in your most holy name. Amen.
A very good evening, all. It gives me immense pleasure to introduce today's resource person, Dr. Ramakrishna Elemanchali. Dr. Ramakrishna Elemanchali is distinguished academician and researcher, currently serving as professor and program head at the Institute of Public Enterprise, Hyderabad. With over 23 years of rich experience spanning both academia and industry, he has made significant contributions to teaching, research, and institutional development. Prior to joining IPE, he was associated with reputed institutions such as ICFAI, Business School, Ethiopian Civil Service University, and Mallareddy Group of Institutions, Hyderabad. He has also gained valuable industry exposure as a financial analyst with leading consulting firms based in the United States. His teaching areas include finance, leadership, and organizational psychology, and he has mentored students at both national and international levels. Recently, he has Dr. Ramakrishna has successfully guided six PhD scholars from Jawaharlal Nehru Technological University, Hyderabad, and Rayalaseema University. His scholarly work is widely recognized with numerous publications in prestigious journals indexed in Scopus, ABDC, UGC CARE, and Web of Science. He has presented research papers at various international conferences held in India, USA, Canada, and Ethiopia, showcasing his global academic engagement. He has completed two funded research projects supported by the United Nations Development Programme and Ethiopian Civil Service University. His research interests focus on public sector enterprises, performance, sustainable development goals, and the relationship between ESG factors and organizational performance. In addition to his academic achievements, Dr. Ramakrishna is committed to societal development. He has conducted numerous free training programs for engineering and management students, focusing on employability skills and career readiness, thereby contributing significantly to student empowerment and community service. Little Flower welcomes you, sir.
Thank you. Thank you, Vijay. Thank you, Little Flower team. Good evening, all the audiences there. Today, I'm going to share some information or knowledge on cross-sectional data analysis. And actually, if you look at the idea of this FDP is ideas for publications using AI and statistical tools. Now, whenever we come across with the publications, normally the statistics textbook says the same thing, but when it comes to the publications, the rigor is what differentiates from one paper from the other. When a reviewer is looking at your papers or editor is looking at your papers, a very important aspect that they look at is what is the rigor which is there in methodology, especially what kind of a data has been collected and how the data has been analyzed, so on and so forth. So this is a core aspect of any paper to be considered for a publication or for a review or not for a review. Yesterday, Professor Shahin would have taught you, giving you outline and information related to the time series data. Now today I'm going to look at the cross-sectional data. Now, let me share my screen. Yes, my entire screen is visible. All right. Now, this is cross-sectional data analysis is a topic, and today's session covers these aspects. Let me think about this way. Like first, we're trying to define data. Many of us, because we are all into research and many of research scholars and doctorates are here, I don't want to explain each topic in detail, just to give you a glance about it. First, we define data and what are the data sources that we get. And introduction to cross-sectional data. Here I'll pay little time and attention. And cross-sectional data, the statistical tests that we can use on cross-sectional data. Then cross-sectional data analysis with some real-world data, online statistical tools. This is a flow of my session. When you're trying to define data, so we define data based on data types and data sets. Data, as you know, qualitative data and the quantitative data. Most of the times when it comes to cross-sectional data, and which I am going to cover today, is basically on quantitative data. As we know, quantitative data related to numbers and all, which we measure, observe, so on and so forth. And on the quantitative data is measured using a structured instruments like a measure questionnaires or any other aspects where we measure quantitative data based on nominal scale, ordinal scale, and ratio, and interval scales. These are measurement scales which we use to collect the quantitative data. And the data categorically, let's say nominal or ordinal, and the numerical data comes into a discrete or a continuous. So most of the times when we measure something on ratio or interval scales, we get a data on a discrete or a continuous. And when you're looking at demographic variables or any other classifications, we get the data on a nominal and ordinal scales. That's factor. Next is time structure and data. So one is a cross-sectional data, which I'll go and introduce. Then we have a time series data based on a time over a time period. We say last 5 years, 10 years, or last 1 month, last today, but every minute. All that is based on a timestamp. So that's a time series data. And third one is a panel data. Panel data is combination of your time series and a cross-sectional data. That means data on a particular variables are measured at some point of a time, but over a period of a time, maybe last 10 years, how the things are happening on particularly related to that. That's a panel data. Now, another aspect of a data that we need to pay attention is a dimensionality. Whether our data is a univariate, bivariate, or a multivariate. So univariate data is if you're measuring on only one variable. Let us say if I'm measuring the age of the respondents, that's a univariate. And a bivariate is two variables where I try to relate one variable with the other variable. And next is a multivariate where we have a multiple variable, more than two variables. Now these univariate, bivariate, and multivariate may be any of the nominal, ordinal, discrete, or a continuous. So you have a univariate ordinal data, univariate nominal, univariate continuous data. In case of a bivariate, you may have a nominal and a discrete or ordinal and a continuous combinations. In case of a multivariate, you may have a nominal and ordinal, and on the other side, continuous data series. So the complexity of data increases when you are looking at different, when you're combining multiple aspects, especially when you're looking for publications in good journals or reputed journals. Most of the times it's the cross-sectional data which actually pays attention. Financial and economics time series data, no doubt in that. But if you're looking at a primary data or secondary data related to subjects, individuals and all, then cross-sectional and more weightage will be given for a panel data. So these two, panel and cross-sectional, will have a more weightage in a methodology. And also when you are using a multivariate in your data set, instead of having a bivariates, if you are trying to measure the relationship between multivariate, then your methodology will be a strong. So these are the key aspects that you need to consider when you are planning to do a research or planning to go for a research publications. Cross-sectional data or a panel data, then try to see that your data will be a multivariate rather than a univariate or a bivariate. With this combination, and in the combination, various scales of measurement, data is captured on various scales of measurement. That makes your methodology much stronger. Then comes to your data sources and all. Now, today in this world of digitalization, cloud kind of a thing, data is available very easily. And as we know, one is the primary data and secondary data sources that we talk about, where we are collecting, using a questionnaires, collecting a data on our own for the first time, according to our research. That's the primary data. And secondary data is data sources which are available. Somebody is trying to work on, let us say, corporate governance. Then a lot of our corporate governance data is available on BRSR reports. Somebody wants to analyze the financial statements. Then hundreds of financial statements are available on web, or economic indicators, inflation, GDP. Likewise, multiple data are available in the secondary sources also. Not only primary, secondary sources also. A lot of data is available there. Then coming to the secondary data for practice, in the sense sometimes we know the statistical test and we want to learn the statistical analysis, but we may not find enough data to practice. Because suppose running a regression for 10 data points is one thing, running a regression for 1,000 data points, or running across a principal component analysis for two variables and running a principal component analysis for seven variables. So if you want to practice, if you want to practice, you need to have a large volume of data. Today, places like Mendeley we all know for different purposes, like where it helps us to write a grammar check or some other aspects. But Mendeley has created a database of its own. So hundreds of data sets are freely available on Mendeley. Kaggle is another data source where you can download time series data, cross-sectional data, panel data, already quoted data. Why I'm saying quoting these is, many times people say that, okay, I have a statistical model, maybe I don't know where to practice it or where to get the data to experiment with all. For experimenting, these are the data sources. Mainly, almost they created a DOI for a data also, digital object identifier for a data sets. Any researcher, somebody done studies in France, US, and all, they collected the data, and now they are uploading all the data into Mendeley, and Mendeley is giving a DOI. And the DOI is shared among the people who are interested to work on, so they can down. So here you get a lot of a cross-sectional data, time series data, as well as a panel data to practice and do it. Then data analysis tools, Excel is a beginner. Then you have a SPSS, because when you are working for a cross-sectional data, it is suggested that we go for a SPSS. It's easy to do. And if you're going for a multivariate and structural equation models, SPSS also got as MOS. SPSS MOS you can use for structural equation models and data sets. My focus here on today is on cross-sectional data. Now let us try to define what exactly I mean by a cross-sectional data. Most of the times we use this data, but we need to define it. So cross-sectional data is defined by its ability to provide a snapshot of a population or phenomenon at a specific moment. So if you're collecting any data using a questionnaire of employees working in an organization today, then it's a cross-sectional data. Or if you're trying to measure what is the economic condition in the country as on date, or during this period of a time, maybe in this 6 months or 1 year period of a time, then there's a cross-sectional data. So in most of the social sciences, the data we use is a cross-sectional data, right? Employee engagement studies or corporate governance related studies, or customer engagement, customer behavior, or sports related attitudes of individuals, child psychology, or organizational psychology. Like all these are part of your cross-sectional data. So cross-sectional data is single point in time. Maybe let us a single point in time in the sense, let us say we collected data for over 6 months of a time. So these 6 months, different observations are collected. That's one. And snapshot approach, it will give you a picture of your population instead of going more detail into it. Then in cross-sectional data, we may have a multiple subjects into consideration. We may collect a data on individuals, we can collect data on institutions or households, firms, countries, anything. Now, take for example, World Bank publishes a lot of data on financial literacy across the world. Now you take current scenario, 1 year, in the sense financial literacy levels of 100 countries or Asian countries likewise. So that is one. And within financial literacy, you can also check individuals, their educational level, their households or household incomes. These are all comes into your cross-sectional data. And another aspect of a cross-sectional data or characteristic of cross-sectional data is its observational nature. So we observe and we record. It doesn't mean that observational study, but recording in the form of questionnaires, recording in the form of survey methods, recording in the form of interviews or anything where we observe and we collect the data. Then it's a simultaneous measurement where if you're conducting a study based on the dependent and independent variables, let us say what causes employees to work more. So then outcome is one variable and causes for a work is another variable. So we measure both the things at the same time, and then we ask the respondents on the same aspect, like why you are working and what is making you to the work. So that means the outcome and the uh, independent variables or explanatory variables, data related to these two will be collected at a same point of a time. Then focus on prevalence. Cross-sectional data helps you to check what exactly is present at this point of a time. And when it comes to the advantage of it, it is a efficiency, it's high efficient. That means we need to collect data at only one point of a time. So if in contradicting to this, if you go for a longitudinal data where you have to collect the same data over a period of a time, maybe past 5 years or 10 years. So, or in future 5 years or 10 years. Let us say some of the longitudinal studies, what we do is we'll start at assessing or understanding the individuals today and how they are going to behave in tomorrow, in the sense after 1 year, after 5 years, after 10 years, like that. But whereas the cross-sectional data is as on date. And another aspect of a cross-sectional data is it's an independent observations. That means each of the respondent or a participant in the study is independent from the others. Like let us say if I'm taking a sample, conducting some study in an IT company where 10,000 employees are there, and I am administering a questionnaire to those 10,000 employees. Each employee response is independent from the other. In the sense, whatever the responses employee A gives, it is different from what employee B gives, employee C gives, employee D gives. So each observation is independent, and cross-sectional data allows us for diverse variables. So diverse variables, as I said, it allows us for collect the data on a multiple variables. You can collect on demographics, or in simple terms, you can collect data on nominal, ordinal, continuous, and discrete scales. And within each also, you can have a multiple. Take for example, nominal scale, you measure designation of the employees, name of the employees, location they are working, hierarchy, like multiple, their family background, family. These are all the things that you can measure on nominal. At the same time, ordinal also, you can put them salaries, how much lower level income, middle level income, higher level income, where you are ranking them based on that way. And also scale variables, you can measure their satisfaction, dissatisfaction, agreement, disagreement, or acceptance, disacceptance, usage, recommendations. So cross-sectional data allows you to collect the data from a diverse variables. So these are the key characteristics that we need to pay attention or need to look at in a cross-sectional data. Then comes is your statistical test. Most of the times, we observe that researchers get confused with what kind of a statistical test to be used on the data set. But here the challenges like this. First is you need to identify the variables, right variables for your study. Second is once you identify the right variables you are studying, you need to collect the right data for your study. And once you are collecting the right data for your study, then you need to use the right statistical test. When saying all is right mean, these three need to be related exactly to the objectives that you set for your research. Now your objective is something, and if your variables are different, if your data sources are different, and your statisticals are different, mean it will not work. So it is all your data sets or all the statistical tests starts from the concept of your objectives of your study. What is that you want to measure in your study, and what is the hypothesis that you want to test. So once you have these two clarity, then the third aspect is you need to define your variables. Whether you are going for univariate, bivariate, or a multivariate, I suggest always go for a multivariate. Now, what are the multivariate variables that you have? And in a multivariate, then how many are dependent and how many are independent? That again you have to pay attention. Then what kind of a data is appropriate for that, and this is on what scale of a measurement I have to get the data that should be linked. And once the data is collected, then what is the appropriate statistical test that I have to use. So now I'm coming to the statistical test. So here data type, if you're if you collected data on a continuous scale, then you want to test the normalities, test for a normality, then your Shapiro will test or Simro test. These two tests will tell you the normality of the data. Then if a test of a means, then one sample t-test or one sample z-test. Then test of a medians, Wilcoxon sign rank test or non-parametric test and a sign test. So these tests test for a normality and when your data is on a continuous basis. Now, what if your data is measured on a categorical data? Categorical data is something which you measure or which you collect using a nominal scale. So category A, category B, like a male, female, or low income, high income, or manager, supervisor, or manager subordinate. So like if you're making a rural, urban, if you're making that some kind of a categories, so that's a categorical data. If you have categorical data, then you need to look at the goodness of a fit. And goodness of fit, chi-square test, goodness of fit is 1. And for your proportional test, one sample binomial test or a one sample d-test for proportions. Proportions are the percentages of your respondents and all. So this is for categorical and these tests are for univariate data. Then coming to the bivariate statistical test, used to examine the relationship or difference between two variables, whether A is related to B or A is different from B, or whether A impacts B or not. For all these cases, we use a bivariate. Here only you have two variables. Now, when you are looking at a bivariate data, you need to clearly define what is your independent variable and what is your dependent variable. So here only two, one independent variable and one dependent variable. Now, what is the statistical test that we have to look at? If you have a categorical data and categories of two groups, only two groups, male, female, rural, urban, or then we say that high income, low income. If you're measuring on a two groups, then your dependent variable is measured on a continuous scale. So age, if it is measured on a number. Now age can be a numerical if it is taken in the number wise, like in the sense age in years and days. Or age can also become a categorical if it is measured on a class interval kind of a thing. So suppose if you are collecting the age of 18 to 25, then it is a categorical data. If you're collecting the age of an individual, let us say 20, another individual 22, then it is a continuous data. So we need to look at how we are getting the data, right? Now, if you are having a independent variable in a category and dependent variable in a continuous, then parametric tests that we are supposed to use is an independent sample t-test, and its equivalent non-parametric statistical test is Mann-Whitney test. Then categorical 2+ groups. There are 3 groups are there where we are talking about a rural, urban, metropolitan. Then you have a 3 groups or employee, supervisor, and a manager, 3 groups likewise. So if your independent is categorical and dependent variable is measured on a continuous, then it is one-way analysis of variance for parametrics and non-parametric Kruskal Wallis test. Now, how is that we need to decide whether we go for a parametric test or a non-parametric test is 2 things that we need to look at. One is your sample size. Preferably if your sample, when it comes to the sample size is greater than 30, generally we go for or large samples, let us say 100, 200, 300, we go for a parametric test. If your sample size is small, then we go for a non-parametric. That's a one way. And second is when you're looking at the data, once you capture the data, in case of a dependent variable like a continuous, we need to check the normality of the data. If data is normally distributed, then parametric tests. If data is not normally distributed, non-parametric tests. There are also other aspects of a parametric test. Normality, if data is not normally distributed or it doesn't pass normality test, then there are certain transformations that you need to make for your data, and this is log transformation or percentages, percentage difference, any other formats where we try to see that data becomes a normality is normally distributed. Uh, to the maximum extent, we try it for normality tests. If it is normally distributed, parametric. After making even transformations also, if your data is not normally distributed, then you are forced to go for non-parametric statistical tests. Now coming to the categories where your independent variable and dependent variable both are categorical, then you have a no parametric sets equivalent to it. In such a cases, you have to go for a chi-square test of independence. So chi-square test we use when we have your dependent variable and independent variable both are measured on categorical scale, that is a nominal scale or ordinal scale. So chi-square test. Then another aspect is if your data is an independent data variable is on a categorical, a small sample, and dependent variable is again on a categorical, then you have to go for a Fisher's exact test. So this is something related to the bivariate statistical test that you need to pay attention. Then the relationships and associations when you're trying to measure the impact of one variable with the other variables. Like your variable 1 is a continuous variable, variable 2 is also continuous variable. Then you can go for a Pearson's correlation. Most of the time, suppose maybe yesterday Shaheen would explained you related to a time series data. So you have stock prices are there and stock market is there. Both are measured on a continuous series. So if you have these two, first of all, we try to see that whether these two are related or not. Or index of index of industrial production, IIPs, then based inflation. Both are measured on a continuous. So first we try to see whether these are related. That's correlation. Then on the other side, if one variable is measured on ordinal and non-normal, then another variable is also measured on ordinal, then we go for a rank correlation kind of a thing. If both are categoricals, then Cramer's V-test or a pi test, and both are continuous, simple linear regressions, and for a binary or continuous post-bias. Now, most of the times when you are collecting data using a questionnaire and scales of measurement, in the sense scales like a scale kind of a thing, we get confused with whether this to be considered as a categorical data or an ordinal data or a continuous data. Multiple arguments are there, but I have no in-depth understanding of why it is considered as a continuous. But wherever I am looking at, wherever we were working or reading a papers, or in all these cases, any data collected using a continuous, using a scales of measurement, a 5-point or 7-point like at scales, the data is considered as a continuous data, not as a ordinal data. So that's the reason why we use linear regressions or analysis of a variance on those data sets. And again, exactly what is the statistical reason? I read multiple places to understand why it is to be considered as a continuous data. Why not? Because you are saying that agreement and disagreement, strongly disagree and strongly agree. So you are looking at strongly disagreement and next level disagree, then neutral, agree, strongly agree. So it is giving you 5 different orders. There's one argument saying that this is a ordinal data, but some others says it's a continuous data. I fail to understand it, but as I'm going with the convention saying that okay, anything which is measured on a scale, it is considered as a continuous data, and based on that we use the simple linear regression, structural equation models. All are built making an assumption that data measured on a scales are continuous data. Then multivariate statistical tests based on your data where there are multiple variables to be considered. So multiple linear regressions where all your variables are measured on your dependent and independent variable. Both are measured on a continuous scale. Then we go for a multiple linear regressions. Multiple logistic regression. It is a categorical outcome from multiple predictors. In the sense, your dependent variable is measured on a categorical, but independent variables are measured on a continuous. Then multiple analysis of a variance, test difference in multiple continuous dependent variables across different categorical groups. ANOVA analysis of covariance and Poisson regression used for a counter data, number of something which Poisson distribution kind of thing. Most popularly used are multiple linear regressions and multiple logistic regression, MANOVA and ANOVA. So in statistical analysis, when you're trying to write a good paper, try to see that your data have a multiple statistical tests. Then in addition to that, if you are trying to build a questionnaire or trying to build an instrument, or some instrument is already available there in the market, or some authors has been promoted that and you want to use that for your purpose, in such a case, we are forced to run some analysis like a principal component analysis, then factor analysis, cluster analysis, discriminant analysis, and finally structural equation modeling. Now, structural equation modeling has become a norm of the day, because many papers we see that it is coming with a structural equation modeling. And if you want to perform structural equation models, then you need to have your scale, which is to be having a principal component analysis and confirmatory factor analysis. Once these two are there, then structural equation models. So yeah, structural equation models where you have a multiple variables and flow will be there. There is independent variable, dependent variable, in between moderators and mediators, and all these variables are measured using a same questionnaire where you have to identify this questionnaire and all. So this becomes more rigorous, and authors or reviewers or editors love to see such kind of a rigor in your research paper. Nowadays, I'll show you one or two examples. It is very difficult to explain you now that structural equation modeling, everything and all. Structural equation model, we can have separate FDP only on cross-sectional data and structural equation models. Any of the colleges who are there or present, we can float a program exclusively on statistical analysis. Now, before I move to the this statistical analysis part and all, I would like to tell you certain things. Maybe you're looking at this is a program which talks about research, publications, and AI and statistical tools. Deliberately, with the discussions with Vijay, we coined in such a way that AI and statistical tools, in a sense, conventional statistical softwares applications, both need to be taught or introduced to the participants. Why? Because even AI is there, a lot of a programming now, any statistical test I am talking about cross-sectional data analysis, if you give it to the Python will run the analysis and give it to you. But as a research, and second is, in many instances, going with a conventional statistical tools is very easy when comparing with going for an AI. And if you are using an AI, if your data volume is very large, then you can use AI. Otherwise, using AI doesn't make any sense. Just I'll give you one simple example. Yesterday, day before, yesterday is a holiday for us. I'm working on some large data, something related around 60,000-70,000 pages of data which has been collected and sourced. And from that 60,000 pages of data, I want to get some insights. So in such a case, using an AI makes a sense, because being a human being, I can't read that 60,000 pages. Even if I read also, I will not be able to understand it, not able to get the insights. And by the time I get the insights, the idea will go in vain. Then I tried working with this on using, this is a panel data. I tried working with AI, And since yesterday morning around 8 o'clock, I started till today 8 o'clock. 24 hours it took for me to train the model and to get the insights from it. Every time I'm asking it to do something, it is failing, and again rewriting it. Almost 24 hours of continuously sitting in front of computer. I was able to make some sense of the data. Now, why I'm saying this is 24 hours continuously sitting with the system, doing your work. It makes a sense. Getting data, analyzing from a data, it makes a sense because the volume of a data is so huge. So 50,000 data point, 50,000 papers I'm talking about. 50,000 papers, each page is around 800 to 1,000 words. So much of a volume. Is it? So in such a cases, AI is fine. But if you're doing some small survey methods and collecting a data here and there, for that AI is not so convenient that which can be run in our traditional statistical packages with 2 minutes or 3 minutes. So now I'll show you, demonstrate you two, three things, not in depth of that, just two, three things of how cross-sectional data can be easily analyzed using SPSS. And when the example which I'm going, this is related to a paper published in a journal, and the authors uploaded the data in Mendeley. Paper is also there, data is also there. I read the article, I downloaded the data, and I'm using it for a practice. So just I show you that paper and the data and the data analysis part. Why I'm showing this is this helps us to do a practice of data. Whatever, so far I am preaching about your data sources, mainly articles, high end of calculations. These are all comes into one simple nutshell, and it hardly takes 5 minutes of your time. So let me show you. This is my SPSS. Am I there?
Yes, sir.
All right. Yeah. So this is the paper which is published in elsewhere journal, and I'm not going to read this entire thing, but invited data manuscript. So survey data on Gen Z customer behavior using food delivery apps in Vietnam. This is the article, values of this, data description. Don't worry. That is, data is measured on a demographic variables like gender, age, educational, multi-income, marital status. All these are measured on a categorical data. Then they have a scales of a so here measurement scale with the descriptive statistics like multi-dimensional scale that they used, compatibility, relative advantage, complexity, trialability, observability, attitude, and continuous usage. These are the variables that they used. Then is factor analysis kind of a thing, validity, discriminant correlation validity, experimental design. So this is the paper. Now, if you look at, they have a data which is measured on ordinal, nominal scales or categorical data. These are continuous data is also there, and they have an instrument or a questionnaire with multiple dimensions. I guess they have 7 dimensions there. 25 questions spread over 7 dimensions, and their complexity usage advantages. This is the paper. And now looking at their data. Yeah. This I'll show you the data view and variables view. Here are the variables where all these scale items are measured here. Then your equations are measured, and these are your final average scores. Now, once this data is there, Just we start with a simple assuming that a chi-square, if you want to run a chi-square test or opinion of individuals, whether they're different based on their gender. So let me just simple analysis. Your analyze. So descriptive statistics. I'm going for a cross tabs. In the cross tabs, I already selected education. Now I remove this education and I put a gender there. Now gender is one variable which I'm considering. So gender is measured on a categorical. My independent variable. I want to see that whether opinions of respondents are same or different related to just one question I am taking. This is usage of a food. Now in the statistics, a chi-square test I want, and other statistical tests as we were mentioning about pi test or contingency test, gamma test, kappa risk, McNamara test, based on your requirements where you have categorical data and continuous data is there. These are the different statistical tests that you can use. So I choosing a chi-square test. Then going to the cells, chi-square test values. Just I want here this now SPSS has got a new feature called as a create APS style table. That means the table is created according to the American Psychological Association format. And directly take the table and put. I selected that and round the cell count, so and so forth, and continue. Then format, if you want to have a format ascending, descending order, choose. Then if you want to look at observe the data, then you can say display cluster bar charts. Then click OK. Now we are not worried about all the things. So here you have a bar chart. Now respondents, their opinions of on agreement to disagreement is measured. Mostly we see something like a more or less agree, followed by the neutral stance. Then more or less disagree, and totally agree is very limited. So if you look at these two graphs, it says there is no significant difference between male and female respondents with related to this. Now here you have a chi-square test values, which is significance value is 0.85, which is greater than 0.05. So we failed to reject the null hypothesis. So we accept the null hypothesis, saying that there is no significant difference between the opinions expressed by male and female related to this. Now you have a table, a chi-square test, everything is there. And hardly, it took only 1 minute for me to do this chi-square test analysis. Now for these kind of things, we don't need to AI. Here simply we can run. Now another aspect we are looking at is a dimension reduction factor test, because the paper uses a principal component analysis and all. So here I selected all the statements, all these statements which we can see here. So all these statements has got a coding, CPA 1, CPA 2, that is compatibility 1, relative advantage, complexity, traceability. Each has been coded there, and they have a mean and standard deviation values are also there, and followed by factor analysis, confirmatory factor analysis, but we run with a principal component analysis. So here all the variables are selected. Then descriptive statistics, univariate descriptives I want. Then initial solution, I don't need. Significance levels, yeah. KMO Bartlett's test is something related to your sample adequacy, whether sample is adequate for this analysis or not. Generally, when we are looking at sample adequacies, we say that sample size determinations are there, where we give our samples population size, then error term. Based on that, sample is collected 340, but most of the time 390 or 400 is the ideal sample where we get adequacy. But even if you are collecting data of 150, 200, 300 respondents, in such a case, whether the sample is adequate or not, to know that we can use the KMO Bartlett's test. So I'm continuing this. Then extraction method, I'm using a principal component analysis. Multiples are there. Maximum likelihood is the most recently popular one. But let us say for time being, we take a principal component analysis. And here matrices also. correlation matrix, display unrelated solution, I'm not interested. Based on eigenvalues, then continue. Then rotations, multiple rotation methods are available, but I'm picking a Varimax, Qmax or a Quatimax also, okay. And then we want is a rotated solutions and loading plots. Then click continue. Then scores are not required. Fine. If you want to have a scores, fine. Then click OK. Now we have a descriptive statistics for a CPA 1, 4.5 and 0.91. And CPA 1, 4.64 and 0.93 of a standard deviation. But here slightly, we got slightly different output. Standard deviation is 0.9 and 4.65. What is the value here? Yeah, 4.65 and 0.93. So exactly if you look at the values here, the same values which has been reported here, we got the same values here also. Last one is intention 4. Yeah, 4.82 and 0.88. 4.82 and 0.88. Now, there is another reason for looking, and in a sense, putting these two together and running an analysis. One is, nowadays, the journals are asking you to upload the data. Almost every journal is asking you to upload the data. And if you're not able to upload the data, then they are retracting the paper. So, and the reason for this is because now with the advent of AI, we are able to generate a synthetic data. Synthetic data in the sense, all the data, whatever it is there here, I can write a small code to the AI asking it to give me, these are my variables and give me the data. AI is creating a synthetic data. So synthetic data is nothing wrong with the synthetic data, but synthetic data we can use only for practice, not to write a paper. If you are writing a paper using a synthetic data mean, you're clearly saying that that is my data I collected, which is unethical. So synthetic data can be written. Now that's the reason why journals are worried whether the author is using a synthetic data or original data. They are asking to upload the data. That's the first point. And second point is, once the data is there are many times, many possibilities are there. Once we get the result, we can tamper the result. Suppose if you have a SPSS output here, I can copy this SPSS output, put it into a Word document, and also. So one, if I don't find sample adequacy here, now if sample adequacy is not there, then simply I can copy this table, put somewhere, and tinker the data and make it adequate. So because of this, data is asked to upload so that anyone can verify, validate, and recheck it. So this is one reason, and the correlation matrix is done. And based on that, now we have a rotated component matrix. And this has got a 7 dimensions. And each factor is loaded on different dimensions. Component 2, CPS are all CPA 1, CPA 2, CPA 3, CPA 4, having a 0.77, 0.8, 0.7, 0.73. All the 4 variables are loaded on component 2. Similarly, first component RA1 is loaded RA1, RA2, RA3, RA4, and RA5. All these 4 are loaded on component 1, where your values are greater than 0.7. Now the same thing appears here also, in the paper also, more or less, because they run a confirmatory factor analysis. Component values may be little vary from what we are getting, because we are doing a principal component analysis. Then they did a confirmatory factor analysis. Confirmatory factor analysis we can do with the what you call as a MOS. So here I am not demonstrating MOS. That's one. Next is assuming that if my data is here and it has got a multiple variables. So let me say regression is here. So linear regression, all the variables here we have traceability and all. Let me say 1 variables and intention, yeah, complexity as my dependent variable. Then estimates R square or change is not required. Continue. Then simply click OK. So we have a multiple regression here. So R square value, R and R square value, adjusted R square value. Three variables, intention, traceability, and compatibility. Three independent variables and one dependent variable, that is a complexity. And we see that there is a no significant R square value, and significant value is less than 1 F value, but R square is very less. And the coefficient matrix. Now, if you just once I started this demonstration, I paid attention towards time, and now I can see now it is 8. I actually started at 7:48 or 7:50. So in the 12 minutes. Now in the 12 minutes, we were able to principal component analysis. We were able to run regression analysis, and that too. After running analysis, I spent time to explain them. But if you're simply running an analysis, all this analysis can be run in a 5 minutes or a 10 minutes. Now, for running a 5-10 minutes of time, my idea is in these cases, we don't need an AI. We need a conventional statistical packages which we can use. So, when you are using a cross-sectional data, the entire model of the story is that if you're using a cross-sectional data, collect the data and use statistical packages to run this. Do not rely on AI, because AI do not understand exactly the test which you want to conduct and so on and so forth. So this is the core idea of the session. And to put it into concluding aspects, we say that when you are running a statistical test, aiming for a good research paper, things that you will noted is your objectives. First, your frame or your objectives. Second, hypothesis. See that your objective try to use multivariates, and one is multivariates and cross-sectional data at least, or a panel data. That's one. Second is, based on this, you have a multiple variables, dependent and independent, multiple dependent variables, and try to get the appropriate data measured on nominal scales as well as the continuous scales. Then fourth one is use appropriate statistical test to run. And fifth is what statistical package you use. It may be IBM, SPSS, Stata, SAS, or any tool. So this should be the flow. Now this all entire set of these 5 points will be the core of your research paper. To consider or not to consider your paper for a publication or review depends on these 5 factors. So this is my session for the day. Now I'm done. If any of you have any questions, you can ask, please. Yeah. It is outlet, because for me this is in the sense, but everybody is continuing tomorrow also. But technically for me this is Lazar. Tomorrow I may not join. I thank Vijay for taking this initiative and pulling up resource persons from all over the country to take a sessions, and well-architected sessions, one after the other, moving in a sequential order. And many people from different fields and expertise taking these sessions. Congratulations, Vijay, for you and your team for successfully organizing this. And from our IPE side, we always stand front to support the institutions, or any one of you want to conduct similar kind of things, workshops, online, offline, you are most welcome. We'll be conducting. Yesterday we concluded one program with the New Horizon College, Bangalore. So parallelly, this week we run two programs, one with the Little Flower Degree College, Hyderabad, and a New Horizon Degree College, Bangalore, two same time, 7 to 8. Monday I took a session in Bangalore. Tuesday I took a session in Little Flower. Wednesday I took session in Bangalore. Thursday, yesterday is holiday. Friday I took. So continuously from the 4 days, every day evening I am occupied with this. So all the participants request, and we are also happy that Little Flower Degree College is planning to enter MOU with us. Probably we may do it in the month of April first week. So any other institutions who would like to partner with IPE in running this activities and all, most welcome. You can contact us. And my sincere thanks to Vijay and team for giving IPE and giving me this opportunity. Thank you all. Yeah, I'm done.
Thank you, sir.
Thank you.
Am I audible, sir? Good evening to one and all. It is my privilege to propose the vote of thanks for today's enriching session on the 6th day of the 7-day faculty development program organized by the Department of Physical Science at Little Flower Degree College affiliated with Usmania University. We extend our heartfelt gratitude to our esteemed resource person, Professor Y. Ramakrishna, Professor and Team IPE, for delivering an insightful session on cross-sectional data analysis. Sir provided valuable guidance on data sources, statistical tests, cross-sectional data analysis, real-world data, and Sir also threw light on scales of measurement, categorical data, dimensionality of dataset. I would like to express our sincere gratitude to Professor Y. Ramakrishna sir for delivering such a clear, practical and engaging demonstration of SPSS. The session was highly informative and inspiring for all the participants. We sincerely thank our principal, Mrs. Jayanti Reddy, and Director, Reverend Brother John Kallarikal, for their constant encouragement and support in organizing the 7-day FDP. I also thank all the staff members for their coordination and cooperation in making this program a success. A special word of thanks to all the participants for their active involvement, thoughtful interactions, and enthusiasm, which made the session lively and meaningful. Thank you, one and all.
చూడకు ఇబ్బందిగా ఉంది. Thank you, sir.
Thank you.
Thank you. Thank you.
Thank you, sir.
Vijay sir, sir, please ask Ramakrishna sir to please share that full paper in our WhatsApp groups. Okay. Yeah, yes, sir. Thank you.